welcome to my presentation on shift-left security with the security testing pyramid. My name is Andreas Falk. I'm working for a company called Novatec Consulting, located in south of Germany. So we are a mid-sized IT consultancy company doing consultancy around the complete application development lifecycle, from gathering requirements up to operating applications, testing applications, developing applications, architecting applications, all that stuff. And I am part of the security part of that. So I mainly deal with application security, identity access management, the typical stuff that is around application development mainly. So that's why I'm also member of the Open Web Application Security Project, and also a member of the OpenID Foundation that deals with the identity access management. You may have heard from OpenID Connect that builds upon OAuth. So that's that foundation. You can reach me via Twitter or email if you have questions afterwards. So let's dive into the topic of today. So you might know already what is called a testing pyramid. For those that don't know the idea, so the main idea is to show what kind of tests you should have as part of your project. On the bottom, you see the unit tests. So these are also called developer phase tests. So you should have mostly kind of these unit tests. So these tests run pretty fast. They give fast feedback if a developer has broken anything in the application by providing some new functionality. So you should have plenty of these tests. These tests run fast. They have low effort to write those tests. And these tests serve as some kind of safety net for a developer's work day by day. Above that, you have what is called service tests. So these are, for example, integration tests running a Spring container, for example, or a Java EE container. So these service tests have a slower feedback already. So these typically maybe run for several minutes. They also have some bigger effort to write, because usually you also have to deal with database, for example, or calling some other components. So that's why it is a bit more difficult to write those tests. And on the top, you have what is called UI testing, so-called acceptance testing as well. So one example would be Selenium tests. These are tests that are hard to maintain. They break often and have a really slow feedback. So depending on the workflows, these tests typically can also run for 10 or 15 minutes, for example. There's also some more advanced variant of that testing pyramid invented by Gregory or Lisa Crispin. These are two authors of the famous Agile testing book. They describe the unit tests also as programmer tests or component tests. And then the service layer tests, they also describe testing business rules, functional tests, some API service layer testing. And on the top, they name it as workflow tests because these typically must not only be UI tests, but can also be acceptance tests based on calling some flows of combined REST API calls. And on the really top of that pyramid, they also introduce what is called the cloud manual explorative tests. So these are the tests that are not running automatically. So they require much human effort. So that's why they are really expensive. it always needs humans to execute those tests, and these tests have a really slow feedback again. So you should only have really short amount of these explorative tests. So, but what about security in that field? So you don't read anything about security in these typical testing pyramids. So how to deal with security in that field? If a developer is faced with security topics, then the number one thing the developer sees mostly is the OWASP top 10 provided by the Open Web Application Security Project, which I already mentioned. And this is the most prominent list that more and more developers know already. And one interesting fact for you that we have a new version of the OWASP top 10 that has been released just some weeks ago in September. So-called OWASP top 10 2021 version. If you already know the OWASP top 10, you might recognize some changes in between the last version that was published 2017. So the number one, the previous number one section, the injection part has went down from top 1 to top 3 now. So the new top 1 problem in typical web applications is the broken access control. So all that kind of stuff that you can try some different ID in the URL part in the web browser and try to access, for example, different data that belongs to another user. If you can manage to access that other data that does not belong to your user data, then you have a typical problem called broken access control. There are also new kind of topics and also renamed topics. For example, cryptographic failures has been renamed from sensitive data failure. We have a new section on insecure design. I will go deeper into that topic in just one moment. And you also have a completely new section on the 10th section, so the server-side request forgery. So these are typical problems that happen on the server side by providing some data that influences business logic on the server side somehow, or calling other services with malicious contents and stuff like that. So have a look into the new list, so it's quite interesting. So we will have a look deeper into the new topic called insecure design. As you can see on the top right, the OWASPs, in addition, also created some nice icons now for each and every topic. And insecure design, it deals about having security already in concept phase, in architectural phase from the beginning. So from the beginning, you should do what is called threat modeling to model potential threats that are relevant for your application. Like, for example, authentication flaws, access control again, business logic problems maybe, and really key flows in your application should be threat modeled. Then also integrate the security language and controls into your what is so-called user stories. So these are typical stories that are written in the agile context typically. So you write user stories for business cases, but you should also bring security into those user stories. Then what is the main topic of today? You should write unit and integration tests to validate that all the critical flows are resistant to the threat model you have created on the first point. And also compile use cases and also misuse cases for all parts of your application. So also write a misuse case from the perspective of an attacker, what an attacker may want to achieve for one of your business functions, for example. So these are all parts for the new topic on insecure design on the new list. So now you would ask yourself, so how do I find those unit and integration tests that I should create, that I should run automatically for my application? It all starts with having concrete security requirements. So if you don't have concrete security requirements, it's really difficult also to derive security tests from that. So without that, you would write just some greenfield security tests that are really general tests that don't face the concrete security problems of your application. So for that, you typically do a threat modeling on your project to find security requirements. You have your usual business requirements that have to be checked against security requirements. And you have plenty of helpful guides, also again provided by the OWASP. And the most helpful guide that I want to mention is the so-called Application Security Verification Standard that you can see on the left side here. So this standard provides you a really helpful document and also an additional Excel sheet providing really a complete catalog of typical concrete security requirements that are applicable for usual applications, for mobile applications, for backends, for front ends, for every kind of application that you want to build. And this has different sections, like for architecture, authentication and stuff. And with the Excel sheet, you can also check each point of the Excel sheet and check if that requirement is applicable for your application or not. And then at the end, you have checked requirements that you can directly put into your project, create, for example, GitHub issues for that or Jira issues, or extend your user stories with that concrete security requirements coming from that catalog. The good thing is that catalog also provides additional testing hints for each and every security requirement. So you can also more easily evolve your security tests using that document. Then the second one is the Web Security Testing Guide. So this document is also commonly used by a penetration tester to really test your application. So this is a really good reference how to test each and every probable security problem, like how to test the SQL injection, how to test for cross-site scripting, how to test your file upload for different problems, for example. So you have a really good testing guide for testing each facet of your application here as well. And if you have your security test written, then you can recheck the security tests against the OWASP top 10 to check if you have at least covered most of the top 10 entries there with your tests. But the OWASP top 10, I have to mention that and stress that again and again, is just an awareness document. So it's not certifiable. So if the manager comes to you, so your application should be conformant to the OWASP top 10. So that's complete nonsense, complete bullshit. So no application can be conformant to OWASP top 10 list. So this was never intended to be certifiable or to prove anything for your application. So this is just an awareness document. The much more important document is the Application Security Verification Standard. So calling threat modeling. So if you don't know threat modeling, so on the right-hand side, you see a typical data flow diagram for a very easy use case, just for login of users. You have a user on the left-hand side, probably located on the internet. Then you have a login service that is probably running on some cloud service, and you have a user database running on your data center. And what is between these kind of things is what is called a trust boundary. So if you have cross boundaries between the internet and the cloud provider, this is one trust boundary because you need different user credentials to access that login service running inside the cloud again. So a user on the internet cannot access directly that service. So it usually accesses that service via some front end with logging in via the HTTP or HTTPS protocol. And the login service then also uses a user database, also crossing a boundary again to your data center. And for threat modeling, you always ask 4 questions. So what are we working on? So that's the data flow diagram. At first stage, you draw such a data flow diagram for your complete application with all the protocol flows happening. And the second question is what can go wrong? Now you try to identify threats for this data flow diagram that you have drawn before. And you ask what can go wrong. And the third step is what are we going to do about it? So what mitigations can we bring on the table to mitigate these identified threats? And fourth step is always to do some kind of retrospective. So are we finished with the threat modeling session? Do we have to continue that? Did we find all the relevant points there? So there's even a manifesto on that, so you can read that up in more detail. So to the application security verification standard, as you can see, these standards has plenty of different sections here. It also defines 3 levels that you can have requirements for your application. So level 1 basically is the most basic level all applications should have. So all requirements that belong to level 1 are usually testable by some penetration testing. But the default application usually should at least implement all the requirements that are associated with level 2. So these have suitable requirements, like for example for architecture, and also brings in code reviews, has more secure coding guidelines, more standards, more checklists, and also does much more unit and integration tests, and also brings in what is called static application security testing. Level 3 is then intended for high restrictive applications, like if you're building the next banking transfer application, then you might need level 3 for really high restrictive applications. And now we just dive into the testing pyramid on the unit testing layer. On the unit testing layer, you can start quite easy by putting in static application security testing. So put in your Sonar Cube tools and stuff like that, like find bugs, spot bugs, as it is named now, as a successor of find bugs. Then also check for known vulnerabilities on your third-party libraries, like OWASP dependency check can be used there. Also scan your container images if you're pushing them to Kubernetes, for example, and then provide unit component tests. And on that level, you can already check, for example, if you validate input given by user to your application. You can also check partly the broken authentication. So I will show some sample with password policies. And you can also check the typical unit testing parts by just trying to bypass your business logic with misusing some parameters, some maybe malicious calls to your business logic, and try to write negative unit tests for your business logic. Then you can try to check if your exceptions have too much information inside, going to the client side and providing maybe version numbers, framework details, or even password and stuff like that to the client side. You should not do that, and you can test for that as well. You can test if your logging does not include any sensitive data, and you can also test for a secure architecture already. I will also show that in a moment. So what I will show, I always have to check for the time. So I prepared some stuff, but I won't be able to show all the things. So I will also share the link to the GitHub repository with all the tests. There are plenty of test ideas there. You can look that up again later as well. So I will show about static application security testing, secure architecture, and some broken authentication stuff. For static application security testing, there are plenty of free and commercial tools available, like Spotbugs for the Java developers. SonarQube is a quite universal tool. So if you have a really old SonarQube version, it's good to update to that latest long-term version of SonarQube. They brought in lots of additional security checks there. So this is a really good thing to check out. With SamGrep, this is a quite universal static application security tool. So this supports plenty of programming languages from Python, JavaScript, TypeScript, and so on. Snick Code is an example of a commercial tool you can use. You can start for free with Snick Code already, so you can easily install that as a plugin into your IntelliJ and then easily can check that. Also, don't forget about infrastructure as code. So if you're writing Terraform scripts and stuff like that, you can use tools like Checkov and Terrascan that also check for security problems here. With Trufflehawk, also a nice tool, you can check your Git repositories for checked-in secrets, like accidentally checking in AWS API keys into a Git repository is a bad idea, for example. And Trufflehawk can detect those things. Then for vulnerable libs, of course, you can use a tool like OWASP dependency check. And for testing secure architecture and design, you can also test already plenty of things on the unit testing layer. So for example, you can already test broken authentication, so if your password policies are not correctly implemented, or missing input validation. For example, if you use the Java bean validation functionality, you can test for missing annotations here. And also you can test for broken authorization or invalid calls to persistence APIs to mitigate secret injections. All that can be done with a tool called ArcUnit. And the next slide now shows some sample from that application security verification standards. So you can also see how the concrete security requirements might look like from that catalog I mentioned. And this section deals about password policies, password security requirements. So it requires that passwords are at least 12 characters long, that you should be able to also put passwords that are 64 characters or longer. So it's a bad idea to restrict passwords in some kind of length to 20 characters, for example. That makes it really difficult to use that in combination with password managers like 1Password to generate really long safe passwords. Also, password truncation should not be performed, and it should be possible to really use any printable Unicode character in passwords. And also, passwords should be checked against a set of breached passwords, like the have been pawned database of Troy Hunt, for example. And for Java, there is a framework, as an example, called Passai that also enables that. So, time for a short demo. I'll switch to my application. So I have a simple application that tries to also rebuild the functionality that is included in web browsers to store bookmarks for different users that you can use. So it has provided some REST API. And for that, I have different layers. Like, for example, I have an API layer, a service layer, and a data access layer. And with ArcUnit, you can easily test your layered architecture that you don't have any invalid calls. Like, for example, the service layer should only be accessed by the controller layer. And you should not call the controller layer, so the API layer, from any other layer directly. So that is prohibited by that architectural rule. And you can easily write these fluent rules with ArcUnit. So these are the typical things that lots of projects do. But you can also write some kind of special security-related tests here. So, for example, I could prohibit that you should not have any calls to persistence APIs from the API or service layer directly. And even for the data access layer, you can also prohibit calling, for example, low-level APIs like java.sql or Hibernate calls. In my projects, I use Spring Data JPA, so there is no need to call directly Hibernate, and also there is no need to directly call Java Persistence API directly. So all that is allowed to call is just Spring Data APIs in that case, and all other packages are prohibited by that rule. As we can see, I can just run that test as an example, and we might see that that this test will go into red because I intentionally implemented that application now in a insecure fashion. So it takes some time. So it fails because I have calls in some application stuff. So I have calls that directly calls persistence APIs. I also have calls that calls Java SQL stuff, and I also have calls directly baked into my service layer. So, for example, the bookmark service. If I show that, then you might see that we have some problem here at that service. So I intentionally put in some SQL injection in this search method. So as you can see, I did what you should not do. So I just concatenated strings with the SQL statement. I concatenated it together with the input given by the REST API. And this is a typical SQL injection problem. And with ArgUnit, I can easily detect if you try to call that thing from a service which is not intended, and if you also call low-level SQL APIs, that makes it quite easy to implement such insecure patterns. So if you use Spring Data calls only, then it is much more difficult to program around the framework intended way, and you automatically only use prepared statements as a mitigation to SQL injections. So, as I showed this, we can also check quickly if the SNCC code, for example, can also detect some part of the security problem. So this is a sample of a static application security tool, which you can easily install. So it's scanning. So we have already some results here. So it also detected sequence. Also in that bookmark service, also that search location. So it detected that. Also detected some cross-site request forgery. I disabled cross-site request forgery in my Spring security. So it already detected some kind of these stuff. It is still scanning, so that takes a bit longer than usually. So you never know, because it also calls some server-side stuff. So it also detects dependency problems in your project as well. But good news, it even detects some SQL injection already. So continue with the service layer. On the service layer, you can even test for more security problems, like then starting up your Spring container, for example, and then really test for authentication for your authorization model with Spring Security. it's really easy to test your complete authorization model in an automated fashion. You can write positive and negative tests for each and every REST API call and try to call that service with the authorized user, but also try to call it with an unauthorized user and then check if you really get the access denied exception that is expected. You can also test for SQL injections. I have a sample that I will show in a moment. You can also test for output escaping, also for security misconfigurations, like for example, cross-origin resource sharing problems. Or even, as mentioned, you can test your authorization layers for broken access control and SQL injections. Also here you have some part of the application security verification standard that deals about access control design. So typically you should enforce access control rules on a trusted service layer. For example, the client side is no trusted service layer, so it's a really bad idea to put access control on your single page application. Always do that on the server side. And also here, put several layers of access control, not only on the UI, on the URL level, but also on the operation level and also on the data access level. Also check that the principle of least privilege exists. Don't give any user administrative access, so that's also a bad idea. And also check in your tests, especially if you have problems in your authorization check itself, then it should not fail in that way that everybody can access your service. It always should fail securely. So in doubt, always deny for all users and don't let any user in if that thing fails. Also some demo. I will just show some demo for catching SQL injections in that case. Let me check for that. So SQL injection is quite easy to test. You can implement. For that tests, I just put in one famous patterns to detect SQL injections, in fact. So this is a typical where clause that you can put in. So you check for some values and put that or 1 equals 1. And with that comment side, you then end up all the SQL statements. And with that payload, you can check if you have a SQL injection problem at hand in your different REST APIs or services in that case. And I put in that payload in each and every API that I have. For example, also in that search bookmarks. And we will try to see if it also detects that SQL injection that is implemented there. So usually you would expect that the result is empty coming from that search, but let's see what that test really returns. So this test runs a bit longer as it is an integration test. It takes a bit more time because it starts up the complete Spring container so that we can also test against the in-memory H2 database and really test for SQL injections. So we should run that in just a moment. Always, you never know how fast it really runs. So I already had run that beforehand to make it a bit faster, but now you see that the test actually failed. So we did not get an empty result. Instead, we get what we often see with SQL injections. We got the complete database contents that are preloaded there for the application instead. And this is a typical sign that we detected a SQL injection. So that was only one idea of plenty ideas I have in that repository. You can grab that URL here. So this is the bookmark service with all the tests contained here. And the next section, the last section that can be fully automated is the dynamic application security testing part, also called DAST. Here you find typical tools like OWASP SAP. So that's also a free web proxy tool that also has some automatic scanning suite on board. So you can just use that tool as a proxy in between your client and server side, and then just run security scans again. This is important against your own application. Never run these active scanning tests against an unauthorized application. So don't run that on an internet service of your likes. So you will get trouble with that provider of that application, because that would be quite illegal to run that tool against an unauthorized application. But it's a good thing to have OWASP SAP installed next to your IntelliJ Eclipse IDE, for example, and always regular run that tool against your own application, even locally. There's also a commercial part of that tool, like Burp Suite. So that's a tool that is used by lots of penetration testers. You have also specialized tools like SQL Map, Nmap, or Gatling. With Gatling, you can run load testing, stress testing. With that, you can also check how your application behaves under high load, if it still correctly checks for authorization stuff, for example. And with this OWASP SAP tool, you can quite easily integrate that into your CI/CD pipeline, because it provides several Docker containers you can use in several variants of scanning. So the fast one is the baseline scan. It just runs a passive scan, which is quite safe, which does not try sequence injection problems and stuff like that, but just try to detect some patterns that might be insecure in the request response fashion. The API scan is especially useful for REST APIs. You just throw in Open API definition, like your Swagger Open API definition as a file, and then it automatically scans all that endpoints. But here also with an active scan, so it tries to do sequence injection, cross-site skipping, all that bad stuff against your REST API. The full scan is then testing the complete application with also spidering of the application, trying to find all the URLs automatically. And this can run maybe for hours, depending on the size of your application. So only integrate baseline scan or API scan directly into your daily CI/CD pipeline. So full scan would be suitable for nightly scans. So we can also have some short demo on that. I just try to run that tool. So I prepared it already. So I have running my application here. Let's see. So I have started up the application already here. So it's a Spring Boot application. And now with the SAP tool, I can easily try to scan the API of my application. So let's start it here. So this takes a lot of time. So we will just continue with the presentation, and we will have a look one moment. So the next thing would be, so if it loads, should automate that things that are shown up to now, from static analysis to the dynamic security scan. You can make all things here. And the most top level of the pyramid then deals with explorative testing, doing security code reviews, and also we see the typical pen testing on that level. So explorative security tests deals with defining some testing charters, as it is named. So here's an example: explore some functionality with injection attacks so you can discover security vulnerabilities. A very useful web browser plugin for this is called Bug Magnet. With that installed, you can easily have a right click on each and every input field that you have in your application and try to put in some malicious, some strange input that is generated directly with that add-on. It also includes sequence injection, cross-site scripting problems, but also encoding problems, like you can try to put in emojis, for example, or unusual character sets. Then according to penetration tests, this is the pattern I often see still currently in most projects, like for example, in here, as you can see, so we have continuous deployment at hand, and from time to time you do functional penetration tests, whereas the attacker works 24 hours, 7 days, so the attacker tries to break into your application all the time. Whereas you can only be safe in these 2 penetration testing points. So the deployments in between are completely blind spots. You never know how secure these are. And this is a cause why I recommend doing the security testing as part of your projects in automated fashion, to also be safe in between these randomly executed penetration tests. As a summary, you should have security on each and every layer of your testing pyramid. So that is really the outcome of today. So put security tests on each and every layer here. And also very important, so you may have heard DevOps, DevSecOps and stuff like that. So I see the Sec is a silent part of DevOps. And it's really important that you should show also empathy in your daily work. So vice versa. So security should maybe try to perform some steps as part of a developer, and also developers should try to understand the security people better, so we can work together more closely and bring up more secure software. So before handing questions, I would just quickly show the results of the level stuff, like cookies without same-site attributes, but also detected cross-site scripting weaknesses, and also again sequence injection at that search, but also on a different location. So luckily we also found plenty of problems here as well. And with that, I'm open for any questions.
Yeah, thank you. Thank you, Andreas. Yeah, dear participants, if you have any questions, I invite you to join the Q&A room with Andreas just after this talk. You will find the link to the Q&A room in the discussion menu. And yeah, you can share your questions with audio or video, like ask live, or you can write them in the chat and Andreas will answer them in the Q&A room. So thank you so much once again for supporting Devoxx Ukraine this year. Hope next year we'll see each other in person in Ukraine.
Yeah, that would be great.
Yeah, thank you.
Thank you very much and have a good day.
Thanks.